Hello everyone, welcome to pipehenge.com. When we install the HDPE pipe above grade, sometimes it can be very tricky. Compared to steel pipe, HDPE pipe can have a very significant thermal expansion and contraction under the same temperature change. And it's also very flexible. The good news is we have developed a great tool for you using equations in the handbook of a PE pipe. And our intention is to provide designers a very easy way to evaluate several typical above ground HDPE pipe installations, including suspended on supports, continuously supported and cradled in clamps, or simply be placed directly on the ground. So let's take a look. Um, like all our other tools, we provide imperial and metric versions. And to switch back and forth, all you need to do is just to press the buttons on the top, imperial and metric. So for this example, let's use imperial for just assuming that the project's in the US. And it's the same pipe input data for nearly all our PE pipe calculation tools. We can change the dimension standard, which is IPS is more common. Let's say this pipe is 18 inch and maybe DR17. We go for P4710, it's more common. Installation temperature, let's say we install at a relatively cold day, 50 Fahrenheit, and the design temperature of this pipeline can go to 120. So that's pretty much all we need for the pipe input, and you can double check the pipe parameters here. What's the OD, what's the wall thickness, and the coefficient of a linear expansion, which is used to calculate the length change in the section below, is a typical value recommended by handbook of a PE pipe. And coming down the first section, if your pipe is just simply placed on the ground with no restraint, and you just let the pipe to freely snake around on the ground, and you want to figure out, for the temperature, design temperatures you put in here, what's gonna be the length change, and this is the section for you to figure that out. So let's say this pipe is around 1,500 feet long, and as you can see, the theoretical length change will be almost 100 inch. And you just want to make sure that when you pipe, pre-snaked or just placed on the ground, you have the room available to take this the length change. So the total length at the end will be almost 1,508 feet. And scroll down. Let's say you will have the anchor points. You want to design anchor points for your PE pipe above grade to take all the thermal force. And this is the section you really need to pay attention to. Again, all the equations were recommended by PE handbook. And as we can see, for this case, the anchor we design must be able to handle about 35,456 pounds force. And if your pipeline is simply placed on a platform on the ground with intermittently restrained, it's a little bit tricky. So for this installation method, we have to be careful because we can't set the restraint too close to each other. We don't want to overstress the pipe. So if you restrain the pipe too closely, you have a chance to over the maximum permissible pipe wall strain, because the pipe tends to deflect laterally if you restrain along the pipe where it is continuous supported from below. So we basically preset the maximum permissible pipe wall string is a 5%, which is also recommended by the P handbook. And in this case, the minimal distance between restraint points should be 22 feet. Of course, you can go over that, but there's another issue that sometimes the pipe can only have certain lateral deflection between the restraint points, which is the delta Y shown here. Let's say this pipe is being placed in a channel or placed on a platform with the U-bolt or clamps every so often. So we have to adjust the spacing between the restraint point to make sure it's in the range. So in this case, it's going to be over 22 feet, and we say we have to make the lateral deflection under 48 inch. So let's change it to maybe 60 feet apart. And then look, the lateral deflection will be reduced to under the 40 inch. And at the same time, it's still over the minimal distance between the restraint point to make sure the pipe wall strain is less than 5%. Okay, so this is for the pipe vertically continuously supported, and then you have clamps or soil berms intermittently. And if you simply place above grade pipe on suspended supports, and this is the section you need to pay attention to. So the first input is the density of internal fluid. The default is about water. Of course, if you deal with outer fluid or you have different density, you just need to tick and manually put a number. Let's say this is seawater, so let's say it's 64 pound per cubic feet. And the maximum deflection between supports, again, typical value is 1 inch is the maximum deflection. You can go a little bit more conservative if you have to, but we definitely recommend we use 1 inch. So in this case, we have a summary of the outputs, including weight of fluid, 86.7, weight of the pipe. This is all in pounds per foot. We basically converted the weight of pounds per foot. And so this is the typical value we have in the database, and we can calculate recommended support spacing. So in this case, the recommended support spacing is 12 foot apart. And again, like all other tools, you can generate a cool report for you to file it or to show to your client or just communicate it with other team members. And in this case, since there's several cases in these tools, you basically can choose what a calculation include in your report, because sometimes, let's say you only have pipe supported on pipe supports, you don't really need to know the thrust load, you don't have anchor points, or it's not the restraint intermittently in continuous vertical support case. So you just unclick this, and then you can have a report owning for the suspended on pipe support sections. Of course, this things above is all atypical. We put it in. Or if your projects involve the HDP pipe that has anchor points that you designed, you want to figure out the size of the anchors and based on the soil bearing capacity, and you also place the pipe on the ground with soil berms every once in a while. So you can click this too, and let's see, then you should have only the thermal thrust load and restraint intermittent case. So you don't have the suspended on pipe support section here. So like all other tools, if you choose to use metric system, then everything should be converted to metric units, and so as your report. So that's everything about this great tool. If you have any suggestions or things you want to see to improve, please contact us. Please visit our website at www.pipeeng.com. And I look forward to hearing from you.